Have you ever stopped to think about what holds our world together? I mean, literally. Well, today we're diving into the family of materials that form the iron backbone of our civilization. We're talking about ferrous metals. Let's get into it. So, what's the connection between a towering skyscraper, the sharpest knife in your kitchen, and the car you drive pretty much every day? The answer is all around us, but we almost never think about it. It's a material that starts its life as just a simple rock. And that material is part of a group we call ferrous metals. You know, the name kind of gives it away. It comes from the Latin word ferrum, which means iron. So here's the main takeaway. Any metal that we call ferrous has iron in it. That's the one ingredient that unites this entire family. All right, to really understand these metals, we've got to go back to the very beginning. We're starting deep inside the Earth with a massive, fiery process that first brings iron into the world. You see, metals like iron aren't just sitting around in the ground waiting for us to pick them up. They're actually locked inside rocks, and we call those special rocks ore. So to get to the metal, you first have to get the ore. Getting from a simple rock to a usable metal is, well, it's basically a three-step journey. First, you mine it. Then, you separate out all the junk you don't want. But the real magic, the big transformation, is that last step, reduction. It's just a fancy word for using a ton of heat to strip away oxygen and finally release the pure metal. And for iron, that incredible fiery transformation happens inside this beast of a structure, the blast furnace. The best way to think about it is like a giant industrial stomach, just melting down all that ore to separate the iron from everything else. Now, the very first thing that comes out of that furnace isn't steel. Nope, it's this raw, kind of impure stuff called pig iron. And it actually gets its name because way back when, the molten iron was poured into these molds on the ground that looked a little like a litter of piglets. This stuff is our base material, all ready to be refined. So, we've got our raw iron, but how do we get from that to the super strong, super versatile material we all know as steel? Well, it all comes down to one little secret ingredient. And this, right here, is the central question of our whole story. What is the magic element that takes simple raw iron and turns it into the world-changing material that is steel? You're probably going to be surprised by how simple the answer is. It's this, less than 2%. That is it. A tiny, tiny amount of one of the most common elements on Earth is the entire key. And that element? It's carbon. So here's the bottom line. Steel isn't just pure iron, it's an alloy, a very carefully controlled mixture of iron and carbon. Just by adding a tiny bit of carbon, we completely change the properties of the iron. It's a total game changer. And this is where it gets really, really cool, because by just tweaking that tiny amount of carbon, we can create a whole spectrum of different steels, and each one has its own unique personality. Just look at this chart. The differences are tiny, but they have these huge effects. That mild steel with less than 0.3% carbon, it's tough and it's bendable. It's perfect for things like car bodies or construction beams. But if you push that carbon past 0.6%, you get hard, sharp, high-carbon steel. That's what you want for a drill bit or a really good chef's knife. See? It's all in the recipe. But, you know, making steel is a little bit like cooking. Sometimes ingredients you don't want get into the mix. In this case, we're talking about elements like sulfur and phosphorus. These little impurities are a huge problem because they can make the steel weak, even brittle. But metallurgists, they have this really clever trick up their sleeve. They add another element, manganese, which basically cancels out the bad effects of the impurities, and that keeps the steel strong. Okay, so we've pretty much cracked the code on steel, but it's not the only important member of the iron family. Let's zoom out a bit and meet some of its other relatives. This table shows you just how diverse this family is, and there's a really clear pattern. Take a look at cast iron. It's got way more carbon, which makes it incredibly strong under compression, perfect for an engine block. But that strength has a trade-off. It's brittle. You can't really bend it. Now go to the other extreme, wrought iron. Here we take almost all the carbon out, and what you get is tough and ductile, great for bending into things like decorative gates. And then there's the superhero of the group, stainless steel. For that, we add totally new ingredients like nickel and chromium. And that creates a material that isn't just tough, but also fights off rust. It's all about different recipes for totally different jobs. So, we've gone all the way from our rock in the ground to a whole family of engineered metals. But how does this raw material actually become the world we see around us?
Well, the metal doesn't just show up as a big lump. It's delivered in these standard, ready-to-use forms. And these shapes, they're not random at all. They are engineered for maximum strength with minimum material. So whether it's a massive I-beam for a skyscraper or a thin sheet for a car door, the metal arrives ready for engineers and builders to make, well, just about everything.
It's pretty amazing when you think about it. This simple partnership between two elements, iron and carbon, literally built the modern age. Which kind of leaves us with one last thought. If iron and carbon built our world, what elements, what new alloys and materials are going to build the next one? Thanks for tuning in to this explainer.